Let me talk about sedimentation rate first. That one's pretty simple. Basically, so in this example, you're taking out blood from a vein, you're spinning it in a centrifuge to make this process happen really fast. Well, if you don't put it in a centrifuge and you have a vial of blood, it'll still settle on its own, again, because it's a suspension. But people that have infections, if you take somebody who's battling an active infection and you put their blood in a vial, it will actually settle faster than a healthy individual. And that's called sedimentation rate. So actually, the less time it takes your blood to settle, the higher likelihood it is that you're battling an infection. So the results of this will be time, right? You actually measure how long it takes until the sedimentation is complete. So a very small amount of time for something to settle down makes it increase the chance that you have an infection. The reason for that is because the antibodies and antigens are reacting and binding up with each other, and therefore they fall out of solution really, really quickly. They fall down to the bottom. It's the same reason that certain water is actually much more clear. So water with really little pieces of sediment in it will stay brown, like rivers tend to be this way. They have very silty sediment, so it stays suspended. It takes forever for that water to get clear. But if you go down to the Bahamas, it's some of the densest sand. That's why the water's so clear, is that you stir up the sand, it just falls immediately. Anybody know what I'm talking about? Really clear water, it's amazing. You like read a book at the bottom. You try to make it dirty, you can't, because the sedimentation rate is so high that it keeps it really clear. Well, your blood kind of behaves more like the water in the Bahamas when you're sick. It's basically what sedimentation rate is. Now, bleeding time and coagulation time, that's a tough one. So make sure you address those together, because if you don't, you'll be like, wait, aren't they the same thing? And they're similar. Have you guys talked about blood clotting yet? Mm-hmm. All the factors and crap? Oh, God. It's horrible. All you need to know is fibrin and fibrinogen, I promise. But bleeding time. So bleeding time is exactly what it sounds like. Cut your skin. We'll start the stopwatch right when you cut the tissue, and then stop it when you've stopped bleeding. That's all bleeding time is. It's pretty straightforward. Now, coagulation time is different, though. That's removing blood from your body, putting it in a tube or in a petri dish, and measuring how long it takes to coagulate. So instead of running, if you've ever bled on something, you've seen this happen. If you didn't clean it up, it'll sit there and it'll dry out. But it's not just the drying, it's actually coagulating, too. So one, coagulation time, is measuring the intrinsic ability of the blood to clot, basically, or coagulate. Bleeding time is measuring that coagulation, but there's also all the stuff the tissue does to stop you from bleeding. So they're two separate things. But normally they're working together. But again, the coagulation time is intrinsic to the blood. It's the blood's ability to stop bleeding. Whereas when you cut yourself, your arterioles, they constrict. There's a lot of other things that go into you stopping bleeding, and you only measure that in the bleeding time test.
Do we need to know the difference between the IV-induced method and like how long it'll take?
No. No, we don't have to. I just want you to conceptually know the tests. Okay. You don't have to know any of the specific values except for hematocrit. Okay. And I really just want you to know the normal values, because you guys are all going into clinical settings. That plus or minus 5, that's for like healthy individuals. And you're going to be dealing with much more variable numbers than there, but it's good to know what the average normal number is, which is 42 and 47 for hematocrit. All right, so any questions about those blood tests? I'm going to start talking about blood typing next. That's probably our hardest topic. So